In today's video, we're going to explore how we can reduce unwanted energy transfers in particular by using thermal insulation and lubrication. And the idea in this video isn't to memorize everything, but to understand the principles so that you could suggest how to reduce energy loss in a particular exam question. Let's start by considering a typical house. Most people like their home to be nice and warm even if it's freezing cold outside. In order to achieve this, though, we need to reduce the amount of heat energy that escapes to the outside environment. And there are a whole range of ways that buildings are adapted for this. First, we want to make sure that our house is sealed closed to make sure that air isn't able to pass out of our home, because otherwise we would lose heat energy by convection, which, remember, is when heat is transferred through liquids and gases. This is why we have foam seals around our doors and windows, and one of the reasons why we draw our curtains at night. Second, we need to reduce heat loss by conduction, which is when heat is lost directly through a solid like a wall or a window. To achieve this, houses tend to have thick walls that are made from materials with a low thermal conductivity, which means that they don't conduct heat very well. Houses also tend to have cavity walls, which is where there are two layers of bricks with a small air gap or cavity between them. This air gap reduces conduction because air is a really poor conductor. The problem, though, is the air does allow convection, so we don't really want an air gap either. To fix this problem, we fill the gap with insulating foam, which has lots of isolated air bubbles, so the gap isn't quite solid, but it's also not quite a gas, so there's hardly any convection or conduction. We actually do a similar thing with our windows. If you've ever wondered what single versus double glazing is, it's to do with how many layers of glass there are in single glazing, which is what older houses tend to have. There's just one pane of glass, and so heat is easily lost by conduction. On the other hand, in double glazing, there are two layers of glass with a tiny air gap between them, which again reduces conduction because the heat can't be conducted across the air gap, and so can't be conducted from inside your house to outside. The last thing we need to look at is how to reduce friction, which, remember, is the resistance that an object encounters when moving over a solid or through a fluid. The problem with friction is that it reduces the efficiency of energy transfer and can cause objects to heat up. For example, the friction between the cogs and chain of a bicycle makes it harder to pedal, but by adding oil, which is a type of lubricant, we can reduce that friction and so make cycling easier. Meanwhile, making cars and planes streamlined reduces the friction from air resistance, which allows them to use less fuel, and so it makes them more efficient. Anyway, that's all for today, so if you enjoyed it, then please do tell your friends and teachers about us, and we'll see you next time.